Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on today's video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. Today, we're looking at Unit 7, Quadratic Equations, Lesson 15, Quadratic Equations with Irrational Solutions. The learning goal in this lesson is to find exact solutions to quadratic equations, even if the solutions are irrational. There are two learning targets. At the end of the lesson, when we're done with the practice problems, we'll come back, look at these again, and make sure you've learned everything you needed to be prepared heading into the next lesson. Learning target number 1 says that you can use the radical and plus-minus symbols to represent solutions to quadratic equations. Now, what they mean by this is, if you remember, we talked about rational numbers and irrational numbers. And the irrational numbers were the ones that could not be written as a fraction. And the reason that they could not be written as a fraction was because they ended up being decimals that did not repeat and did not end. So sometimes what we can do is we can leave these with the radical symbol. So something like square root of 2. Rather than trying to come up with a precise number with a decimal, what we can do is just leave it as the square root of 2 and let that be the answer, because that is the most precise answer we're going to be able to get. Then the plus minus symbol, if you remember, I told you that when you took the square root of a positive number, you were going to get both the plus or the positive answer and the minus or negative answer. So what we have is what's called the plus minus symbol, where it's a plus on top and a minus underneath it. And this allows us to write two answers as one and save space and time. So rather than saying the square root of 4 is both positive 2 and negative 2, we can just put plus or minus 2. And learning target number 2 says that you know why the plus minus symbol is used when solving quadratic equations by finding square roots. And that's what I was just talking about. It allows you to save time and space so that instead of solving twice and writing the answers as plus 2 and minus 2, or positive 2 and negative 2, you can just refer to it once as being plus or minus 2. For the glossary terms, we've got completing the square. Our last 3 videos have been about this. The goal in completing the square is to end up with a factored form perfect square on the left, and then we're able to take the square root of both sides and solve for x to find our answer. The next term is irrational number, and this simply means any number that cannot be written as a fraction, whether that's a positive fraction or a negative fraction, or 0. Perfect square. When we say that something is a perfect square, we're saying that it is created by multiplying something by itself. So something like 9 would be a perfect square because it's 3 times 3. Or something like the quantity of x plus 2 squared would be a perfect square because it's x plus 2 times x plus 2. And our last glossary term is rational number. These are all the numbers that can be written as fractions. So obviously fractions are rational numbers. Whole numbers are rational because they can be written as the whole number over 1. Square roots of perfect squares are rational numbers. And any kind of decimal that either repeats itself or has a stopping point would be a rational number because you would be able to write those as a fraction. Now we can begin the practice problems for Unit 7, Lesson 15. The first practice problem simply wants us to solve each equation and write the solutions using the plus-minus notation. And there's a couple different ways we can write these answers, and it's really going to depend on what that answer is as to what we would consider the best way to write it. So let's look at number 1. On number 1, we have x squared equals 144. Well, the opposite of squaring x would be to take the square root. So we're going to take the square root of both sides. When we do, the square root of a square is just the thing itself. And then on the right side, the square root of 144 is both positive 12 and negative 12. Since that's a whole number, that's how we're going to write it. Plus or minus 12. Number 2. For this one, we have x squared equals 5. Again, the opposite of squaring x would be to take the square root. So we're going to take the square root of both sides. Now on the left, the square root and the square cancel each other out. So that leaves x. Now on the right side, the square root of 5 is not a perfect square. It's going to be a decimal that doesn't repeat and doesn't end. So for something like this, the best and most accepted way to write this would be that x equals plus or minus the square root of 5. This is the most accurate way to represent the answer, because if I try to change it to a decimal, at some point I'm going to cut it off and round, and so it's not quite as accurate as just leaving it as the square root of 5. The next one would be number 3. Here we have 4x squared equals 28. Well, the first thing I need to get rid of is that 4. And the opposite of multiplying by 4 is dividing by 4. And so I'm going to divide both sides by 4 to keep it equal. This is going to leave me with x squared equals 7. Again, the opposite of squaring x would be taking the square root. So we're going to take the square root of both sides to keep it equal. The square root and the square cancel each other out, and we are left with x equals plus or minus the square root of 7. Again, this is another example where 7 is not a perfect square. So rather than cutting off a decimal somewhere and rounding, the most accurate and the most accepted way to write it is to just leave it as the square root, or plus or minus the square root of 7. Number 4. We have x squared equals 25 over 4. Again, the opposite of squaring something is taking the square root. So we're going to take the square root of both sides to keep it equal. Taking the square root of a square cancels out and leaves us with x. Now on the right, when we take the square root of a fraction, what you can really think of it as doing is taking the square root of the numerator on top and then the square root of the denominator on bottom. And since this is a positive fraction, we're going to get plus or minus the square root of 25 is 5, and the square root of 4 is 2. So we could leave it as x equals plus or minus 5 halves. If you wanted to change that to 2 1/2, you could. If you wanted to change it to 2.5, you could. Or you can just leave it as plus or minus 5 halves. Since what they gave us was a fraction, I'm going to leave it written as a fraction. Number 5. We have 2x squared equals 22. The opposite of multiplying by 2 is dividing by 2. So I'm going to divide both sides by 2 to keep it equal. This is going to leave me with x squared on the left and 11 on the right. The opposite of squaring x would be taking the square root. So I'm going to take the square root of both sides to keep it equal. The square root and the square cancel each other out, so that leaves us with x equals plus or minus the square root of 11. And lastly, number 6, we have 7x squared equals 16. Now the opposite of multiplying by 7 is dividing by 7. So we're going to divide both sides by 7 to keep it equal. That's going to give us x squared on the left equals 16 over 7 on the right. The opposite of squaring something is taking the square root. The square root of something squared is just the thing, so this is x. And then the square root of 16 over 7 can be written a couple of different ways. We can just leave this as the square root of 16 over 7 because 7 is not a perfect square. If you were to try and change it because 16 is, then what you could do is you would say plus or minus the square root of 16 is 4, and you would put square root of 7 on the bottom. But it's not generally accepted to have a radical or a square root on the bottom. So you would then multiply the top and the bottom by square root of 7. That way you're really just multiplying by 1. And that would change it to 4 times the square root of 7 over 7. And we would want to remember plus or minus. So either way would be correct. I would probably just leave it as square root of 16 over 7, plus or minus. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2 wants us to match each expression on the left with equivalent expressions on the right. So, let's look at A. When we have 4 plus or minus 1, that really means it could be 4 plus 1, which equals 5, or it could be 4 minus 1, which equals 3. So when you look at your choices, number 4 is 3 and 5. That means A is equivalent to number 4. Next, on B, when you have a square root that is a perfect square, you can go ahead and solve that. So here we have 10 plus or minus the square root of 4, and I hope you know that the square root of 4 is 2. So this really says 10 plus 2, which equals 12, or 10 minus 2, which equals 8. And when you look at your choices on the right, you'll notice that number 3 is 8 and 12. So B matches number 3. Next one is choice C. This is just a simple whole number plus or minus. So it's either negative 6 plus 11, which is going to equal positive 5, or it's negative 6 minus 11, which is going to be negative 17. And if you look at your choices on the right, that's number 1, negative 17, and positive 5. So C matches number 1. Now D is one of these options where they give you a square root that is not a perfect square. Since this is not a perfect square, we're going to leave it written in the radical sign so that it's as accurate as we can possibly give. So this is going to represent 4 plus square root of 10, or it's going to represent 4 minus the square root of 10. And if you look at your choices on the right, you can see that D matches number 5. And finally, on choice E, they're actually giving you a mixture of radicals here. 16 is a perfect square, but 2 is not. So you can actually go ahead and solve the first one. Square root of 16 equals 4. And then you'll leave the second one written as a radical because it's not a perfect square. So this represents 4 plus the square root of 2, and it represents 4 minus the square root of 2, and that matches choice number 2. So E matches number 2. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3 is going to help explain to you some of the generally accepted practices when it comes to writing and reading mathematical symbols. So number 1 and number 2, I'm actually going to answer together. Number 1 wants to know if the square root of 4 is a positive or negative number. And number 2 wants to know if the square root of 5 is a positive or negative number. And you've probably heard me say numerous times, if you've been watching these lessons, that when you take the square root of a positive number, you get both a positive answer and a negative answer. So for example, the square root of 4 is both 2 and negative 2. But here is the key to what number 1 and number 2 are asking. So number 1 and number 2 are not asking you to find the square root of 4 and the square root of 5. They are simply representing a quantity with these numbers. So when all we're doing is using a radical to represent a quantity, it is understood that we are talking about the positive. So I hope that makes sense to you. And if it's still a little unclear, let's look at number 3, because number 3 is going to help explain what the tiny difference is. They want us to explain the difference between square root of 9 and the solutions to the equation x squared equals 9. And here's what that difference is. Square root of 9 is representing a positive quantity. On the other hand, x squared equals 9 is asking you to find all possible numbers that make the equation true. What this means is that the square root of 9 equals 3, but the solutions to x squared equals 9 are 3 and -3. So there is a difference in mathematics when you're being more precise about how it is written and how it is read. And the difference is that if I'm using a radical to represent a quantity, then if I just have square root of 9, then I am representing the positive 3. If I wanted to represent the -3, then I would put negative the square root of 9. I would put that minus sign to the left of the square root symbol. That way I would find the square root of 9 to be 3, and then that negative would make it -3. But if I'm giving you an equation and I'm asking you to find the solutions, then I am asking you to find every possible number that I could put in for x that would make the equation true. So in that case, we would be talking about +3 and -3. I hope this helps clear it up. If you still have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 4 is our last practice problem for lesson 15. This one specifies technology required because they're going to have us solve these two standard form equations using the completing the square method. Then they want us to graph them on a graphing calculator such as Desmos.com and verify that the solutions are close to each other. So let's look at the standard form equation on the left. The very first step is to make sure that we only have ax squared plus bx on the left. So we need to subtract this 8 from both sides. That's going to give us x squared plus 10x equals -8. Now that we have it the way we want, we're going to identify the b term, which is 10. And we're going to divide that by 2. That gives us 5. So now I know what's going to go in my factored form, perfect square. X squared is created by x times x, and then I'm going to have plus 5. The next step is to take that 5 and square it, which will give us 25. This is going to be the new c term that we add in. If we add 25 to the left side, we must also add 25 to the right side to keep it equal. So now, -8 plus 25 is going to give us 17 on the right side. Now that we have our perfect square, we're going to take the square root of both sides. On the left, the square root and the exponent of 2 cancel each other out. So we're left with x plus 5 on the left side, and we're left with plus or minus the square root of 17 on the right side, because 17 is an irrational number. The next step would be to subtract 5 from both sides. This is going to give us x equals plus or minus the square root of 17 minus 5. So because we're going to graph these and see if they are close, let's go ahead and get some estimates. So in a calculator, we can do 17, then square root. Notice we have this long decimal that doesn't repeat and doesn't stop. This would be the plus square root of 17. Now we're going to subtract 5. And I'm going to go ahead and stop at 3 decimal points. So this would be approximately negative 0.877. That's the first approximation. Now let's do it if we take 17, the square root of it. Now let's make that negative. Now we subtract the 5, and we get negative 9.123. So these are the approximate answers of the accurate answer we have, leaving it in its radical form. So now let's pull up the Desmos calculator. You just simply click into the red one, which is the equation on our left, and you can see these gray dots that pop up. The one on the left is negative 9.123, which is really close to what we had. It's just a rounded to 5 decimals answer. And on the right side, we have negative 0.87689, which is exactly what we got, but rounded to 5 decimal places, as opposed to 3. So we can see that what we got by completing the square and what we got by using a graphing calculator are going to give us the same answers as correctly as they can, but not fully correctly, because the square root of 17 is an irrational number. Now let's look at the equation on the right. The first step is to ensure that we only have ax squared plus bx on the left. So the opposite of minus 11 is plus 11. So we add it to both sides to keep it equal. This gives us x squared minus 4x on the left and 11 on the right. The next step is to identify the b term, which is negative 4, and divide it by 2. This gives us negative 2. Now we know what to write in the factored form. X squared is going to be created by x times x, and the new c term is going to be created by negative 2 times negative 2. So we have x minus 2 squared on the left side. We take that negative 2 and we square it, which gives us 4. We add 4 to the left side as the new c term. But if we add 4 to the left, we also need to add 4 to the right. Now we can see that the right side equals 15 because 11 plus 4 is 15. This gives us our perfect square factored form. Once we have this, we're going to take the square root of both sides. On the left side, the square root and the exponent of 2 cancel each other out, and we're left with x minus 2. On the right side, since 15 is not a perfect square, we end up with plus or minus the square root of 15. Now, the opposite of minus 2 is plus 2. So we're going to add 2 to both sides, and that gives us x equals 2 plus or minus the square root of 15. Now we can find our approximate answers using a calculator. First, we have 2 plus the square root of 15. And this gives us 5.873. If we round it to 3 decimals. Next, we're going to take 2 minus the square root of 15, which gives us negative 1.873. So these are the approximate answers that we're going to match up with the graphing calculator. Now, on the graphing calculator, I already typed the second equation, and it's represented by the blue parabola. On the left, we can see this gray dot is at negative 1.87298, which is exactly what we found, but we rounded to 3 decimals and they rounded to 5. If we go back, we can see that the other x-intercept is at 5.87298, which is exactly what we got, only we rounded to 3 decimals and they rounded to 5. These rounding discrepancies are why we choose to just leave it written as plus or minus the square root of a number that is not a perfect square. If you have any questions about anything that we covered in the practice problems for lesson 15, please leave a comment below and I'll get back to you with any help that I can offer. Now, before we finish this lesson, let's go back, take a look at the learning targets, and make sure that you understand everything you need to be prepared moving forward. Let's review the learning targets for lesson 15. Number 1 says that you can use the radical and plus minus symbols to represent solutions to quadratic equations. Number 2 says you know why the plus minus symbol is used when solving quadratic expressions by finding square roots. So hopefully what you've learned in this lesson is that the plus minus symbol is a shortcut we use when taking square roots of positive numbers. Because when you take the square root of a positive number, you're going to get a positive answer and a negative answer. For example, when I take the square root of 4, I get 2 and I get negative 2. So the plus minus is a quick way for you to write that, save some time and save some space. The reason that we might leave a radical sign when we're finding these solutions is because the number will be an irrational number. Something such as a square root of 2 or a square root of 3. These are going to be decimals that do not repeat and do not end. So at some point you have to round if you try to turn it into a decimal, which makes it an approximation and not an exact answer. So by leaving it in the radical symbol, what you do is you create an exact answer and therefore a more correct answer when you solve. I hope everything I've explained in this lesson makes sense to you. Please remember you can always leave a comment and I'll get back to you with any help that I can offer. In the bottom left of the screen, you should see another video that YouTube believes you will find helpful. In the bottom right of the screen, you should see a subscription button for the channel. If you find this content helpful, I ask that you please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.